In today's video, we're going to talk about more trigonometric functions using the unit circle. Let's start with example 1. Given a point x comma y on the unit circle where the terminal side of an angle with t radians intercepts the unit circle, use the definitions of trigonometric functions to write the formulas for tangent of t, cosecant of t, secant of t, and cotangent of t. Let's start with graphing the unit circle. So you do a unit circle and then you do the axes. Make sure the axes go through the center of your unit circle. All right. And then we're going to label this point x comma y. For the sake of simplicity, we're going to assume that this point is in the first quadrant. For example, this point is right here. And then the coordinates is x comma y. It's just for the sake of simplicity. This point could be in any quadrant on the circle, but in the first quadrant it's easier to visualize the triangle, so that's why I chose to do that. And now let's connect the center and this point. So right here we have this point, this angle of t. And we're looking at this angle of t. To write the formulas of different trigonometric functions, we need to have the right triangle, right? So I'm going to create a vertical line segment passing through this point. And then I have this right triangle. And then in this right triangle, you can label the sides with the values. So let's start with the hypotenuse, right? The hypotenuse of this right triangle is the radius of the unit circle. So that means it's 1. So you put a 1 there. And then using the coordinates of the point x comma y, we know that the base of this right triangle has to be the x coordinate of your point. So that's x. And then the height of this right triangle is the y coordinate of the point, so that's y. And now we have this right triangle labeled. We are ready to write all the trigonometric functions. We can do a quick review. Last time we talked about sine and cosine, so let's start with that first, right? And then we can write the other ones. So sine of t, and then I'm going to write the SOHCAHTOA on the top. So you could kind of look at that at the same time. So SOHCAHTOA, make sure you remember that. And then look at the triangle, angle T is right there. We're going to do opposite divided by hypotenuse. And then for the angle T, opposite is y. And divided by hypotenuse is 1, which is y, right? So that's the conclusion that we got last time. And then we also have cosine of t. That will be adjacent over hypotenuse. So adjacent is x, hypotenuse is 1, so that's x. This is how we used the unit circle last time to find sine and cosine of different angle measures on the unit circle. And then starting today, we're going to talk about the other 4 trigonometric functions. The first one is tangent. So tangent of t, using SOHCAHTOA, I think I deleted this a. SOHCAHTOA, it's opposite divided by adjacent. So using the right triangle, opposite is y, adjacent is x. So this will be the formula. It's y over x. Or you could also say it's sine of t over cosine of t, right? So you could actually expand this, right, as sine of t divided by cosine of t. And this is actually more useful in my opinion. Tangent, you get it from doing a ratio of sine to cosine. And then the other 3, secant, cosecant of t. Cosecant of t is the reciprocal of sine of t, so that means it's going to be 1 over y. And then secant of t is the reciprocal of cosine of t, so that's 1 over x. And then finally, cotangent of t is the reciprocal of tangent of t. So that would be x over y. And now we have these formulas. So starting with tangent of t, it's y over x. Cosecant of t is 1 over y. Secant of t, 1 over x. Cotangent of t, x over y. In practice, we don't really need to find the values of cosecant, secant, and cotangent. This is because we can use the reciprocals of sine, cosine, and tangent. So that means, the last three expressions or formulas right here, you don't need to remember them. You just need to know how you compute sine, cosine, and tangent. Okay, let's use these formulas to actually calculate practice 1. So we're given this point and it's on the unit circle. You're going to find all of its 6 trigonometric functions using the formulas, or you could use triangles. So I'm going to use the formulas since we just concluded those formulas on the left hand side, right? So first thing to do, I'm going to label my points, x comma y, and then using the formulas on the left hand side. So let's also highlight the other two from the previous handout. Sine of t is y, cosine of t is x, right? So let's write it down. Sine of, let's assume the label of the angle is also t, and then you could just use the formula on the left hand side. It's the y coordinate, so that means it's just 1/2. And then you do cosine of t, it's the x coordinate, so that'll be negative radical 3 over 2. And then tangent of t. Tangent of t is y over x. So you do have to do a little bit of calculation. Let's do the calculation somewhere else. I'm going to do right here. Y, so that's 1 over 2 divided by x, which is negative radical 3 over 2, right? So this is what we're doing for tangent. And I know that the result's going to be negative, so I'm going to put the negative sign in the front. And then I'm going to keep inverse flip to divide these two fractions. So keep the first fraction 1 over 2, change the operation from division to multiplication, and then flip the fraction upside down. So that'll be 2 over radical 3. And notice that the 2 cancel out, and we have negative 1 over radical 3. And we need to rationalize this fraction. So I'm going to multiply both the top and the bottom by radical 3. And that will give me negative radical 3 over radical 9, which is 3. So that is the tangent. Let's put it right here. Okay, and then these are the 3 main trigonometric functions. The other 3, we don't need to use the formulas. This is because you just need to use the reciprocal relation to get them. For example, the cosecant of t, right? It's the reciprocal of sine, so flip 1 over 2 upside down, we get 2. And then we have secant of t is the reciprocal of cosine, so flip negative radical 3 over 2 upside down. That will be negative 2 over radical 3. And then we're going to rationalize this because there is radical in the denominator. So you multiply both the top and the bottom by radical 3. This will give you negative 2 radical 3 over 3. And finally, we have cotangent of t. Cotangent of t is the reciprocal of the tangent. Tangent, we got negative radical 3 over 3, so we are going to flip that upside down. So that's negative 3 over radical 3. And then we're gonna, same thing, rationalize this fraction. And this will give you negative 3 radical 3 over 3. And then we have the 3 cancel out, right? So the final answer is simply negative radical 3. Let's highlight all the values that we found. So sine of t is 1/2, cosine of t, negative radical 3 over 2, tangent of t, negative radical 3 over 3, cosecant of t is 2, and then secant of t is negative 2 radical 3 over 3, cotangent of t is negative radical 3. Okay, so practice 2 is completing the table below for common angles. We have these common angles, and these are angles from the unit circle. If you remember, you have the 0 degree, 30, 45, 60, and 90 degrees. So those are the unit circle angles. And I would like you to use the unit circle that we have from last time and complete this table. You're going to start with sine and cosine, and then you can use the formulas that we concluded right here to get the tangent, cosecant, secant, and cotangent. So I would like you to pause the video, do it yourself first, if you could do that, and then restart the video, check your answers. Okay, so for the first one, it's 0 degrees. And you're going to pull out your unit circle, look at 0 degrees. And remember, sine is the y-coordinate, right? So this is the y-coordinate. And then cosine is the x-coordinate. So from the unit circle for the 0 degree, y is 0. And then x is 1, right? So you could do that. And then once you complete those two, you're going to do tangent. So tangent is sine divided by cosine, or you could do y divided by x. So I'm going to do 0 divided by 1, which is 0. And then once you have these three, the other three are simply the reciprocals. So cosecant is the reciprocal of sine, so that would be 1 over 0. And as you can see, this is undefined, right? This is undefined. And you're just going to write undefined. Because you cannot divide it by 0. And then secant is the reciprocal of cosine, so 1 over 1, which is 1. Cotangent is the reciprocal of tangent, so that's 1 over 0. And again, we have undefined. Let's move them a little bit. So that's basically all the 0 degrees. Let's move on to 30 degrees. 30 degrees, for the sine, y-coordinate is 1/2. And then for cosine, the x-coordinate is radical 3 over 2. And then for tangent, we're going to divide sine by cosine. So that's 1 over 2 divided by radical 3 over 2, right? Let's move them a little bit. And I'm going to use keep, invert, and flip to calculate that. And 2 and 2 cancel out. So you have 1 over radical 3. And we're going to rationalize this by multiplying both the top and the bottom by radical 3. We get radical 3 over 3. Okay, then cosecant is the reciprocal of sine, so that will be 2. And then secant is the reciprocal of cosine, so that will be 2 over radical 3. And then we're going to rationalize this. And this will give us 2 radical 3 over 3. Cotangent is the reciprocal of tangent. Since tangent is radical 3 over 3, or I could actually just use this one, right? I could use this one, 1 over radical 3, and then I flip it upside down. I get radical 3 over 1, which is just radical 3. So that will be for 30 degrees. Next, 45 degrees. 45 degrees, the y-coordinate and the x-coordinate, they are the same. So we know that the sine and cosine will both be radical 2 over 2. And then tangent, because it's the ratio of sine and cosine, it's going to be 1, right? Because, you know, the two fractions dividing, they're the same, so it's a 1. And now we're going to do the reciprocals to find the other three. Cosecant will be the reciprocal of radical 2 over 2. So that'll be 2 divided by radical 2. And then we're going to rationalize this fraction, multiply both the top and the bottom by radical 2. And this will be 2 radical 2 over 2. Cross out the 2, we get radical 2. Let's move this a little bit. Okay, for secant, it's the reciprocal of cosine, which is the same as before, so you don't need to calculate again. It's also radical 2. And then cotangent is the reciprocal of tangent, which is 1 over 1, and that's 1. Next, 60 degrees. The y-coordinate is radical 3 over 2, and the x-coordinate is 1 over 2. And then for the tangent, we're doing radical 3 over 2 divided by 1 over 2. keep, change, flip, radical 3 over 2, invert, and then flip it upside down, and then we cross out the 2's, it's radical 3. Cosecant is the reciprocal of sine, so that will be 2 over radical 3. And we did do the rationalization right here. So I'm just going to copy the answer. It's 2 radical 3 over 3. Secant is the reciprocal of cosine, so it's the reciprocal of 1 over 2, which is 2. And finally, cotangent is the reciprocal of tangent, so that would be 1 over radical 3. And we did do the rationalization right here, which is radical 3 over 3. And finally, 90 degrees. 90 degrees, the y-coordinate is 1, the x-coordinate is 0. And then tangent is sine divided by cosine, so 1 divided by 0, and that will be undefined. All right, and then we have cosecant. So cosecant will be the reciprocal of sine, which is a 1. And then secant will be the reciprocal of cosine, so that's another 1 over 0, which means it's undefined. Cotangent is the reciprocal of tangent. So that will be 0 divided by 1, right? That would be 0 divided by 1. And that is 0. Okay, so we completed this table. And as you can see, some of the cells are undefined by nature, by how we divide by 0, which is undefined. But these are the common angles, and there are 6 trigonometric functions. Let's move on to second page. Example 2, use reference angles to find all 6 trigonometric functions of negative 5 pi over 6. So for this one, there are a few ways that you could solve this. This is asking you to use reference angle, but you don't really need to. You could use unit circle. Just for the sake of the problem, I'm going to use the reference angle. The first thing I'm going to do is I'm going to convert this angle to the numerical degrees so that I know where it is. It's negative 5 times 180 degrees, right, divided by 6. And then if you calculate that, it's going to give you negative 150 degrees. So commonly, how would I solve this is I will add 360 because, you know, this is a negative angle. It's not on the unit circle directly, but there is a coterminal angle that is on the unit circle. So you just add 360, right? If you add 360, this will give you 210. So basically means you're looking at 210 degrees on the unit circle and you are able to find out all the 6 trigonometric function values. But because this is talking about using reference angle, so I'm going to approach it slightly differently. But just so you know, there is a quicker way, which I just demonstrate right here. You could use 210 to finish the rest. But for now, I'm going to use the reference angle. Let's visualize this angle. I'm going to do a coordinate plan. And then you have your starting angle, starting side, right, initial side right here. And because it's a negative, we're going to go clockwise. And it's passing the 90 degrees, but before the 180, so by 60 degrees. So that means it's probably going to be somewhere here. That will be how you rotate it, which will give you the terminal side. And this angle measurement is negative 150 degrees. Using this graph, we can write down the reference angle. So the reference angle will be this angle right here. It's the smallest acute angle between the terminal side of the angle and the horizontal axis. And if you do a simple subtraction, it will be 30 degrees. So we know the reference angle, right, is 30 degrees. And that means you're going to use your values for 30 degrees to figure out all 6 trigonometric functions, but mainly just the 3. Let's write it down. So you have your sine of negative 5 pi over 6, right? And then you have your cosine of negative 5 pi over 6. And then you have your tangent of negative 5 pi over 6. I'm using radians, which is the representation given by the problem, but we know it's negative 150. And then in the third quadrant, because the terminal side of this angle is in the third quadrant, we know the sine of x coordinate is negative, and the sine of y coordinate is also negative. And that tells us that your sine and cosine will both be negative. So it's going to be negative of sine of 30 degrees, which is the reference angle. Same thing with the cosine, it's going to be negative of cosine of 30 degrees. And the sine comes from the graph, because the angle terminal side is in the third quadrant, so you know that those two coordinates have to be negative. And then you just use 30 degrees to write down the values. So for 30 degrees, the sine is 1 over 2, so that would be negative 1 over 2. And for x, it's radical 3 over 2, so that means negative radical 3 over 2. Okay, and then once you have them written down, you could calculate tangent, right? Tangent is simply sine divided by cosine. So I'm going to write like this: sine of negative 5 pi over 6 divided by cosine of negative 5 pi over 6. And then you just do a ratio of these two numbers, which we did on the previous page. We did two positive values, and now we're dividing two negative values. The result is going to be positive, and then it's going to give you 1 over radical 3, and we rationalize that. It's going to be radical 3 over 3. So we did that. Let's see. On the first page right here, so if you need calculate again, you could look at the calculation that I did right there. Okay, and once you have these three values, you could write down the other three, right? Let's move this a little bit because it looks like I'm running out of space, but it's fine. So the other three, I recommend that you put them side by side. So you have your cosecant of negative 5 pi over 6, right? So that would be the reciprocal of sine, so that would be negative 2. And then secant of negative 5 pi over 6, that's the reciprocal of cosine, so that would be negative 2 over radical 3. And we're going to rationalize this, and that gives us negative 2 radical 3 over 3. And finally, cotangent of negative 5 pi over 6. That's the reciprocal of tangent. So that would be 3 over radical 3, and which simplifies to radical 3. So we did do that earlier on the first page. And that will be the 6 trigonometric functions of negative 5 pi over 6. And then for practice 3, I'd like you to complete this on your own. But I will give you the visualization of the angle and the answers. Let's change it to a different color. So this angle measurement, if you do a substitution, it's negative 7 times 180 degrees divided by 4. And that will give you negative 315 degrees. So you could do a visualization of this angle, starting with the initial side, right? And it's negative, which means we're going clockwise, and it's going to go past 270 degrees, right? Because it's 315, so we're going to go beyond that, and it's approximately right here. It's go beyond by 45 degrees, so this will be the terminal side. And this angle measurement is negative 315 degrees. And as you can see, this angle is equivalent to 45 degrees, right? So you could actually add 360 right here to see that this is coterminal to 45 degrees. So that means you just use 45 degrees. Those are the values, which are right here. These values, right? These values will be the answer. But we're going to use reference angles. So I'm going to say the reference angle, it's right here. That's the reference angle. It's 45 degrees. And then the, let's write it down. Reference angle is 45 degrees. And then you're going to do the 6 functions. So we have sine of negative 7 pi over 4, cosine of negative 7 pi over 4, tangent negative 7 pi over 4, cosecant negative 7 pi over 4, secant negative 7 pi over 4, and then cotangent negative 7 pi over 4. If you use the reference angle, sine will be the same as sine of 45, because in the first quadrant, the y-coordinate is positive, the x-coordinate is also positive. So it's going to be the same as sine of 45 degrees. And cosine is going to be the same as cosine of 45 degrees. So if you write down the value, it's going to be radical 2 over 2 for both of them. And then for tangent, it's going to be tangent of 45 degrees, right? You could use the table from the previous page. It's going to be 1. And then for the remaining, it's pretty much the same as 45 degrees. You could just copy from the first page. So cosecant is the reciprocal of sine, which is radical 2. Secant is the reciprocal of cosine, it's also radical 2. And cotangent, reciprocal of tangent, which is 1. And that's practice 3. Okay, section number 2, recognizing and using fundamental identities. So let's highlight them. First one is tangent, right? We did do this in the first example. Tangent of t is sine of t divided by cosine of t. You absolutely need to remember this. And then the other 3 are the reciprocal relations. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. And then if you expand that, it's equal to cosine of t divided by sine of t. That is slightly less useful, but if you can remember that, that is also good, because sometimes when we prove some of the identities, you might need to use that. Let's look at example 3. We're going to simplify secant of t divided by tangent of t. So first, secant of t is, you're going to use, actually, let's change the color. So secant of t, right, is, you're going to use the identity above. It's 1 over cosine of t. So usually we use the identity to convert the 3 minor trigonometric functions to the 3 major trigonometric functions. So what are the minor ones? These 3 are the minor ones, the cosecant, secant, and cotangent. And then sine, cosine, and tangent, they are the major ones. We usually convert to the major ones. That's what I did right here. And then tangent, you don't need to convert it, right? But we can actually do something about it, which is using the first property, sine of t divided by cosine of t. So among these 3 major ones, if you have a tangent, chances are you're going to convert tangent to the ratio of sine and cosine. So that's what we're going to do right here. It's sine of t over cosine of t. And now if we're going to simplify secant of t over tangent of t, we're dividing these 2 fractions. It's 1 over cosine of t divided by sine of t over cosine of t. And then I'm going to use the keep invert flip. So the first fraction, you keep it 1 over cosine of t. Invert the operation from division to multiplication and flip the second fraction upside down. That would be cosine of t over sine of t. And notice that the cosine of t cancel out. So our final answer is 1 over sine of t. You could just use this as the final answer, or you could use the reciprocal of sine, which is cosecant, as the final answer, which is probably better, right? So that would be the simplified expression of example 3. All right, I'd like you to practice with practice 4. Try yourself first. See if you could simplify this using one of or multiple identities above that we highlighted. Okay, so for this one, I'm going to first convert tangent of t, right? So tangent of t, we're doing tangent of t times cosine of t. Tangent of t, I can use the first identity right there, write it as sine of t over cosine of t, and then multiply this by cosine of t. Notice that the cosine of t cancel out, so our final answer is sine of t. That will be the simplified expression of practice 4. Okay, section 3, alternate forms of the Pythagorean identity. So in one of the lectures, we talked about one Pythagorean identity. I don't know if you still remember that. We used the unit circle to demonstrate that, which is right here. The cosine square plus sine square is 1. This comes from the unit circle, the equation of the circle. And there are two alternative forms of this Pythagorean identity. So for example, this one right here, 1 plus tangent square equals secant square. How do you do that is you divide the first identity cosine square plus sine square over equals 1 by cosine square on both sides. So let me actually show you maybe right here. Cosine square t plus sine square of t, this equals 1, right? This is the Pythagorean identity that we discussed before. So what you can do is you could divide everything in this equation by cosine of t. So I divide this by cosine of t, and then divide this by cosine of t. If I do that, cosine squared divided by cosine squared, that's 1, plus sine squared divided by cosine squared. You could use the identity right there. Sine divided by cosine is tangent. So this is tangent square. This is tangent square. And then on the other side, this is the reciprocal of cosine squared. What's the reciprocal of cosine? It is secant. So that would be secant squared. And that's how you get the second identity right there. For the third identity right here, you can try and think how you get this from the first identity. So I'm going to leave that to you to think about it. It's very similar to what we did right here. You are able to get the identity yourself. Example 4. If cosine of t is 12 over 13 and t is in quadrant 4, find the values of the other 5 trigonometric functions. So this is a very typical problem that you may encounter on the final exam. Given you one of the trig function value and where the angle is located, you're going to find the other 5 values. So first, let's identify the signs of the angle, right? In terms of the quadrants. So we know that it's in the 4th quadrant. If it's in the 4th quadrant, it's right here. We know that the x-coordinate is positive and the y-coordinate is negative. So I recommend that you do something like this just to remind you. And this indicates that our cosine has to be positive, which is the case right here. Our cosine is positive, and then our sine is negative. Our sine is negative. And we're going to use the Pythagorean identity to figure out the value of sine along with the graph that we have right here. Using the first identity, we have cosine square plus sine square equals 1. So I'm going to plug in the values. It's 12 square over 13 square plus sine squared equals 1. And then you subtract both sides by 12 square over 13 square. This will give you 25 over 169. So I'm skipping some of the calculations, but if you do it, you're going to get 25 over 169. And because this angle is in the 4th quadrant, we know that sine of t has to be less than 0. So we know sine of t has to be you just take a square root of 25 over 169 and then add a negative sign in the front, which is negative 5 over 13. And again, you could use your calculator for this. And now let's write down the 6 trigonometric functions. I usually like to follow an order. This is the order that I prefer. So I start with sine, followed by cosine and tangent. All right. I'm going to find these 3 values first. Sine, we just found it. It's negative 5 over 13. Cosine, it's given by the problem, 12 over 13. And then tangent is the ratio of sine and cosine. Let's do it somewhere else. So it's going to be negative 5 over 13 divided by 12 over 13. And that's negative 5 over 13 times 13 over 12. And we have 13 cancel out. So the final answer right here is negative 5 over 12. Let's write it right here. Okay. And then for the other 3, you simply take the reciprocal. Cosecant of t is the reciprocal of sine, so that's negative 13 over 5. And then secant of t is the reciprocal of cosine, so that's 13 over 12. And then finally, cotangent of t is the reciprocal of tangent, negative 12 over 5. And that's example 4. I'd like you to practice with practice 5. And then when you're ready, you could restart the video. Okay, so for this one, they give you secant, it's negative. They also tell you that the angle is in between 0 and pi, which is between 0 and 180 degrees, right? So the first thing I'm going to do is I'm going to use the reciprocal relation between secant and cosine to find cosine, because that is a property that we can quickly apply and find. So cosine of t is the reciprocal of secant, right? So that means it's going to be negative 8 over 17. It's negative. And then the angle is in between 0 and 180. So let's do a quick coordinate plane graph. The angle measurement, they tell you it's in between 0 and 180, which means it could be in the first quadrant or the second quadrant. But how do you know which one it is? You're going to look at the value of cosine. Cosine is negative, and that means it has to be in the second quadrant. As you can see, in the second quadrant, this angle is in between 0 and 180, and also the cosine is negative. So that's how you deduct that the angle has to be in the second quadrant. And once we know where the terminal side of the angle lands, we're able to write down all 6 trigonometric functions. Let's start with sine. So I'm going to use the Pythagorean identity. And again, for this one, you can also use, by the way, this identity right here, right? Because the question gives you secant. You could use this identity to find out tangent along with the sines. But personally, I prefer this identity, so that's why I'm going to use this identity. I have cosine squared, so that would be a squared over 17 squared, right? Plus sine squared equals 1. And then if you solve this for sine squared, we're going to get sine squared is that's 5, 3, so 15 over 17 squared. Oh, actually, no, sorry. It's 25 times 9, so whatever that is, that's the numerator. And then you can take a square root. In the second quadrant, sine is positive, so we know that sine of t is the square root of that, so that would be 15 over 17. And now let's write down the 6 trigonometric functions, starting with sine. This is my preferred order, right? Followed by cosine and tangent. Sine, we just found it. It's 15 over 17. Cosine, we calculated earlier, negative 8 over 17. Tangent is sine divided by cosine, so let's calculate what that is. Sine is 15 over 17 divided by cosine, so negative 8 over 17. It's going to be negative 15 over 17 times 17 over 8. And then you cross out the 17. We got negative 15 over 8. Okay, and then we're going to write down the other three using the reciprocals. Cosecant is the reciprocal of sine, so that's 17 over 15. Secant is the reciprocal of cosine, negative 17 over 8. Cotangent is the reciprocal of tangent, negative 8 over 15. Okay, the last section of this handout is about the period of trigonometric functions. The best way to do this is probably visualizing. You visualize all the 6 trig functions using a graphing calculator, and you're going to see that cosine, sine, secant, and cosecant, the graph repeats itself every 2 pi. So that is the period. And then the graph of tangent and cotangent, they repeat itself every pi. So that is the period. So let's see if I can actually show you. So you could go to decimals, and then you could just use the functions, right? So let's see if it works. Let's see. I'm kind of want to see where it is. Okay, so I'm going to use the keyboard. I think the keyboard is probably better. So let's, for example, I'm going to type sine of x, right? And as you can see right here, the sine of x, the graph repeats itself about right here. So this point, 2 pi. As you can see, you could kind of see where the pieces that repeats itself every 2 pi. And then you could see the range, the highest point is 1, the lowest point, negative 1. So those are different properties about sine. And then you could do the same thing for other, like the cosine. And because the secant and cosecant are the reciprocals of cosine and sine, so they will have the same period. Now let's look at tangent. Tangent will be slightly different, right? So if I remove the cosine, I have tangent. Tangent, the period is pi. So you could see this blue curve repeats itself every pi. It might be kind of hard to see, but looks like the graph is in between negative 2 and positive 2, and this piece repeats itself, right? But to be more specific, it's actually not negative 2 or positive 2, but it is pi. It is pi. And how do you know that is you could actually just compare, for example, these 2 points. From the origin to the point to the right, it's pi comma 0, and then you have 2 pi comma 0, 3 pi comma 0. So as you can see that there's a constant difference between them, which is pi. So that's how you know that the period of tangent is pi. And because cotangent is the reciprocal of tangent, it will have the same period. All right, so that basically concludes this handout. Thanks for watching.